Hello and welcome to the Transformation Health Team's Tool of the Month video series for the month of March 2026. My name is Brad Sollenberger, a lean coach for the Transformational Health Team, and in this video, I will be covering the basics of calculating sample size for measurement plans, observation studies, and confirming results. Let's begin. In order to confirm an effect, you will need to observe or collect a sample of observations or outcomes. The question is, how many? There are many statistical calculations that have to be answered. However, it's easiest to go to an online tool like calculator.net to help you determine the number of observations needed for your measurement plan. You will first need to determine the margin of error. To do this, you will need to establish your confidence level. The general rule of thumb for this is to use a 95% confidence level for research or healthcare safety or a highly technical manufacturing process. For business or service processes, even healthcare services, it is acceptable to use the 90% confidence level. Say a clinic sees 5,000 patients a year, but you anticipate you can collect observations from 20 patients next week. You can input this in your sample size and population size respectively. The population proportion is the fraction or percentage of individuals in a population that possess a specific characteristic or outcome. Let's say you're measuring turnaround time, and currently only 20% of patients are seen in the goal time of 30 minutes or less. You would enter 20%. If you're not sure what the population proportion is, go ahead and just put 50% to make the most conservative sampling scenario possible. After entering all of this, you will have your margin of error. The next step is easy. Find the sample size calculator and enter the confidence level, population proportion, and population size again, as well as your calculated margin of error. Voila! Now you know the sample size for a statistically rigorous observation plan or measurement plan. But what if that's actually still a lot and not really feasible? You'll often hear truisms like 30 observations is statistically significant, or just get 30 samples. Well, this isn't technically correct, but it is, however, directionally correct and still useful. Why is that? It comes from the idea that many datasets fit a normal distribution, or are assumed to at least, and we often have to deal with small samples. Because of that, the student's t-distribution chart provides the t-score, or correction factor, to estimate how close a sample distribution is to the overall population distribution. You'll notice if you squint really hard that as the sample size approaches infinity, the correction factor, or t-score, gets smaller and smaller with each additional sample. 30 was simply adopted as a rule of thumb because it's a round number, easily achievable in almost every scenario, and the immense diminishing returns after sample size 30 makes it a perfect place to test your sample data. Is it statistically significant? No, but often that is good enough and helps you know more today than you did yesterday. Thank you for watching this month's presentation on sample size. If you would like to learn more about lean tools, principles, and available transformational health trainings, please use the QR code on the right or visit us on our Pulse page. If you would like direct project coaching, development opportunities, or are interested in other ways to infuse lean principles into your daily work, please email our coaching team at tht@ucsd.edu. Thank you for the difference you make every day in our patients' lives.